Welcome to Making It with Terry Wollman, the show that explores the secrets, successes, and strategies for making it in the music biz. And now, here's your host, Terry Wollman.
Welcome to episode 143 of Making It with me, your host, Terry Wollman. I really appreciate you joining us, and I encourage you to stay mindful and safe as we work together as a community to get through this global health pandemic. Also, please vote. Every voice matters in the upcoming election, including yours. I hope you find my recent conversations with artists Bob James, Tony Basil, Gino Vanelli, Boney James, and Holocaust survivor Rose Schindler inspiring, comforting, and entertaining. You can find all of our episodes on Apple Podcasts, Spotify, or just go to terrywollman.com/podcast. I'd like to share with you the intention that inspires this podcast. Time passes quickly, and I've learned that we should do what's in our hearts and do it well without apologies or excuses. I encourage you to create your life and art in your own unique way and express your artistry with joy and abandon. Be willing to work uncompromisingly for what you believe in. Success will have a better chance of finding you when you live your life with integrity, focus, and passion. Be selfish with your discipline and selfless in your performance. And don't forget to have fun along the way. My guest today is the perfect example of that. Today's a very special show, inspired by my remarkable visit to NASA's Jet Propulsion Laboratory, only 7 days before the final moment of Cassini's nearly 20-year voyage in space. Let me tell you about my guest. Dr. Linda Spilker is a planetary scientist at NASA's Jet Propulsion Laboratory in Pasadena, California. She has participated in NASA and international planetary missions for over 40 years. As Cassini Project Scientist, Dr. Spilker led a team of over 300 international scientists focusing on studies of Saturn's rings. She has received a number of NASA awards, including 2 NASA Exceptional Service Medals and a NASA Outstanding Public Leadership Medal. Dr. Spilker's remarkable career at JPL began as her first and only job out of college. She enjoys yoga and hiking in national parks, including her favorite park, Yosemite, and is married with 3 daughters and 9 grandchildren, including 6 granddaughters. Dr. Linda Spilker, welcome to Making It.
Thank you, Terry. It's a pleasure to be here.
It's really nice to have you, and we are, can I say, new friends? I kind of feel like you're my friend because we met pretty recently, but I felt a connection with you from having visited you and your team, your family, your staff at work.
Right, and shared the Cassini experience with the end of the mission.
Yes. And, my visit to JPL led to having you on the show, but it also inspired my new album, Cassini's Last Dance, which is dedicated to you and your team, the passionate visionaries of JPL. So I just wanted to say thank you for the inspiration.
You're very welcome, Terry.
One of the things that was a big surprise to me is the connection between science and art. I had never really given that, I never gave that a lot of thought, I suppose. I mean, I've always loved science and I've been curious about it, but I don't know that I've ever really connected them so much as getting to know you a little bit recently.
Yeah, I think there is really a connection between the two, in that when I look at the planets and I look at the data that Cassini sent back, I see a tremendous amount of beauty, but also perhaps there's a link to music. I'm not a musician per se, but perhaps there is a link between the music of the planets as seen in their mystery and beauty. I'm a ring scientist by training, and one of the images that I often show is an image of Saturn's ring particles circling the planet in an intricate cosmic dance, slowly spinning and jostling each other, creating graceful waves and towering peaks in a ring system that's so vast it would fit between the Earth and the Moon. And then there's the tiny moon Enceladus, with active geysers at the South Pole, shooting icy particles and gas into space. Enceladus would also create music of its own with these tiny particles shooting into space, creating a new ring, while others fall back to the surface like falling snow.
Are you a poet? Because that is so profoundly beautiful to me and so clear and truthful. Do you write poetry?
I don't write poetry, but I like to tell the story of Cassini.
Yeah.
And part of that story is to turn Cassini's discoveries into pictures. I tend to think in pictures. And so if I can give you a picture of what it might be like to float in the rings or go down to the surface of one of Saturn's moons, then that's the story I like to tell.
And there's the joy and the passion that what I'm seeing right now and hearing from you is what I experienced when I went to JPL, times 150 people that happened to be there that day on your team. Or, you know, it was and is contagious and visceral and real. I mean, and that was the most beautiful, sweetest surprise of the visit. I mean, of course, I was thrilled, and we were thrilled. I was there with my wife and two dear friends to see the life-size twin of Cassini. You know, like to be standing right there and seeing what it really looked like, or what she really looked like, and looking down on the you can tell how excited I am still, looking down in the lab where the missiles and where they're all built, you know, or the satellites are built, and then also the thrill at the end of this tour that we had of being on the observation deck of Mission Control and looking down. We could hear you. There's no glass or anything separating. So looking down and listening to them, it wasn't even solemn. It was just, I mean, it was intense, but there was a sense of sadness, but there was joy and excitement and intense focus, of course, because this was the final 7 days of essentially a 20-year mission. I mean, longer than 20 years, right? I mean, you were developing this well before the project started.
Right. It was really back in the late 1980s that the mission concept got started. It was just an idea, and it was a joint idea between NASA and the European Space Agency that several scientists got together, pitched to their agencies that we need to go back. In particular, there were 2 flybys with the spacecraft Voyager in the early 1980s. And one of their goals was to try and unveil the mystery of this moon, Titan. Titan's about the size of the planet Mercury, but it has a thick atmosphere. We were hoping to peer through that atmosphere and see the surface of Titan, a moon with a thick atmosphere. But alas, the cameras and the instruments on Voyager just couldn't see through what's the equivalent of a really smoggy day in Los Angeles, this thick smog, to see the surface. So the idea was go back with Cassini, carry a probe named Huygens to parachute through the atmosphere and land on the surface of Titan. And that's exactly what we did, seeing this surface for the very first time. And what a surprise to see lakes of liquid methane, river channels carved by these lakes, to see methane rain wetting the surface of Titan. A remarkable place, dunes, weather, just incredible. And that was just the beginning of Cassini's visit.
How long has the collaboration been going on with other countries to this level? Something that when the space program began, I remember as a kid, was very insulated. We didn't want to share information. That was my perception. That there's the American. There was a competition. It didn't feel like a collaboration. And what I'm hearing you say is that it was extremely collaborative.
In the beginning, it may not have been as collaborative, but certainly as we get to today, and it's just so easy. Used to be so easy to go from country to country and hold meetings there and visit, and it just made sense because we could pool our resources.
Right.
Both NASA and the European Space Agency had a finite amount of money, put our resources together, and get a mission bigger than either institution could do by itself.
Mm-hmm.
That was a lot of fun. We held one meeting a year with Cassini scientists somewhere in Europe. One of the hosts would be one of the scientists on Cassini. And so we got a chance to see what it was like, where other people were, what the cultures were like, what those cities were like. And it was really a very exciting way to interact with our colleagues. And I think the science overall was richer for having participation that went around the globe.
Do you see that? Well, how are you adjusting to not traveling? Because you typically travel a lot. Part of your job, I know, is to lecture and to lead workshops and share information, and that's certainly changing. And just as our music business has changed, how are you feeling that change right now? Is it limiting, or is it in some ways opening up other possibilities, or both?
It's really a little of both, Terry.
Mm-hmm.
It's limiting in the sense that a big part of these meetings and conferences is getting together with the over coffee or lunch or dinner and having those separate interactions. And so that part of it is gone, that sort of that human interaction. And it's replaced by lots of virtual meetings and telecons, and those are good. You can still exchange information, but it's more one-on-one. You only have one person speaking at a time. You can't go off and have a splinter discussion with a separate group of people. You're not sitting around the table, maybe having a beer, having dinner, and having separate conversations. And so that's the part I miss, that human interaction. And I enjoy traveling. I enjoy seeing other places and what it's like there. So I miss that aspect of it. And I guess part of this whole lockdown that we're in has made me appreciate so many things that I just took for granted. If I wanted to take a trip, you say get away for a weekend, I could just call up, get my plane flight, off I'd go, I'd come back. And I didn't even think twice about it. And now I'm thinking, let's see, how far can I go and where can I go in my car?
Mm-hmm.
Because that's probably the safest way to travel right now.
Have you been able to get away with your husband or kids, grandkids, to do any hiking or anything recently, or are you just in lockdown?
Well, I did go up and visit. I have a daughter in the San Francisco area, and did have a chance several months to go up and visit and see my granddaughter, be there for my grandson's first birthday. Went up with my other daughter and her granddaughter. So we sort of got all the grandkids, the local grandkids together.
Mm-hmm.
And that was really a lot of fun. And I have a granddaughter locally. And so we get together with that family. We go, there's a pool in the neighborhood. We go to the pool. We hike around the neighborhood, and we visit each other's houses, have dinner together. So
Mm-hmm.
Not any long trips and no national parks so far.
Yeah. Well, I think we all look forward to that coming back.
Definitely.
Yeah.
Definitely.
That's cool to hear you say that about your love of travel and the connection of being in a room with somebody and the personal aspect of and interpersonal aspect of it. So not just the science and the numbers and the facts, but the human factor. It's very much what we're all missing in our business as well.
Right. And Cassini, we were together for so long, from the start of the mission and the first meeting we held back in 1990 for over 30 years. And so in a lot of cases, our families, our kids had a chance to get to know each other and grow up together. And we had a chance to travel together. And often after a big Cassini meeting, I'd get together with a group of friends, and we might stay a little bit longer where we were, or maybe visit another couple of cities while we were in the area. So really a chance to get to know these people very, very well.
What do you remember about that first meeting, that Cassini meeting, where where it was just an idea?
Early on, when it was just an idea between Cassini and the European Space Agency, it wasn't even called Cassini yet. There was tremendous excitement, especially by those of us who'd worked on Voyager. Here was a chance to go back to this fascinating system where we had left so many questions unanswered, and there's just a palpable excitement about it. And even more so, that very first meeting of Cassini after the instruments and teams were selected, getting everyone together for the first time, and everyone had their few minutes to introduce themselves and talk about why they were part of Cassini. that was so exciting. We knew we were witnessing the birth of a mission and being part of it from the very beginning.
You know, one of the things that fascinates me about your job in your life, and you might chuckle at this, is that you've had essentially one job your whole life. You know, the longest job I've ever had was 3 years music directing a late night talk show. You know, I mean, on the other hand, I mean, I have a steady, I think similar to you, it's not just one job. You know, it's in one place essentially or for one company, but your job has evolved the whole time that you've been doing it. But I'm just wondering, what is that like? I mean, you got out of college, you went to JPL and they were impressed and they hired you and you continued your higher education and you're still there.
That's right. It's interesting, Terry. When I first started at JPL, I thought, well, I'll probably work here for a few years and then maybe I'll go to Lockheed or some other company and move around and get additional experience. But I started at JPL and I started right within a few months of when the Voyager spacecraft launched. And I got to go to the launch. I got to see this spacecraft, this rocket lift off the pad, Voyager begin its journey to the outer solar system. And I was hooked. Each planet we flew by, first Jupiter, and then Saturn, and then Uranus, and then Neptune, each one was a separate adventure with its own new discoveries and new findings and times that were so exciting I couldn't even sleep. I'd sit there and watch the pictures come back and be talking to the people around me and pointing at the pictures and saying, what do you suppose that is? What do you suppose that means? And I was hooked. So after Voyager, when the opportunity came along for another mission back to what I have to say is my favorite planet, because as a ring scientist, I think Saturn has the coolest rings. So chance to go back to Saturn, it was just felt natural to stay and go back again. And this time, not just that quick flyby, but instead stay for 13 years in the system. So what a wonderful opportunity. And along the way, working on other types of missions. You know, I worked on a concept to go to Mercury. I've worked on other concepts to go back to Uranus and Neptune. I think that would be really cool to have orbiters around those two worlds. So I've had other little interesting things to do along the way too.
The other thing about the 13-year exploration that Cassini did, it doesn't include, or we haven't mentioned yet, the 7 years it took to get there. You know, from the launch to the arrival at the planet. What were those 7 years like? Did that fly by? Was it tedious or was it enthralling, or were you working on other things as it was being guided there and maintained?
Well, during that 7 years, we were working on what we wanted to do when we got to Saturn. That when we launched, we didn't have the software or the tools, or we didn't have the plan laid out. So what we did is we spent 7 years laying out the plan in excruciating detail, like scientists love to do, almost minute to minute, of what we were going to do over those 4 years, so that when the data started coming back, we could look at the data and spend our time on the data, and then use any new discoveries or new science to make changes if we needed to what we wanted to do to get the very most out of the mission. And that time, it did fly by. In some ways, lots going on. There was a good chance with my family as my daughters were growing older and you know, ultimately going on to high school or whatever. So just getting bigger and growing up as well.
What well, first of all, I have so many questions. Just and because I'm enthralled and fascinated. What is a ring scientist? I never heard that term until I met you.
Oh, okay. When I say I'm a ring scientist, I'm a planetary ring scientist. And that means that I study the rings around primarily the planets in our solar system. And it turns out that the 4 giant planets in our solar system, Jupiter, Saturn, Uranus, and Neptune, all have rings. Tiny particles circling in close to the planet, close enough where the gravity of that planet, say gravity of Saturn, would tear apart any attempt to form a moon. So you have moons, and as you get closer to the planet, that's where you're going to find that you have these ring systems. And Saturn's rings are so interesting because a lot of the same physics that you use to talk about spiral galaxies like the Milky Way galaxy or the other beautiful spirals that you can see with a really good telescope. That physics applies to these really beautiful waves in Saturn's rings. And so to think about the scale of a galaxy down to the rings around Saturn, just really exciting. And then that ring disk, you can think of it as an analogy for perhaps the disk of material that formed the planets in our solar system. So if we can figure out what's going on in the rings, maybe we can sort of understand, how did our solar system form? How did it evolve? Where is it going? And the rings are, just like I say, are intrinsically beautiful, whether you look even with a pair of binoculars or a small telescope. Saturn has very striking and probably very young rings. In fact, one of the things Cassini discovered is that perhaps the rings are 10 to 100 million years old. Maybe they formed around the time of the dinosaurs. You know, if you're a dinosaur, maybe you look up and go, look, all of a sudden that planet looks different. Now it has a ring. Perhaps a comet or a little moon got too close. Saturn's gravity pulled it apart and turned it into these billions of particles that now orbit Saturn.
You spoke about, again, I'm enthralled, and I have, and we're going to post some of the links that you sent me that are for NASA and JPL with these beautiful, exquisite images that Cassini was sending back through her life to you, and they are spectacular. They really are gorgeous. You were talking about developing technology during those 7 years to kind of figuring it out while she was on her way there. But this is technology that you all invented that is now going to be used for future projects.
Right, that's right. We invented the software, the programs that we needed, and we kind of learned as we went along. If we needed to do something that was a little more ambitious, then we get together with our programmers and engineers and the scientists and figure out a way to do it. One good example is somebody said, hey, we want to track this place in the rings and move the cameras with it so there's no smear in the pictures. And so they went off and the programmers went off and they said, okay, we figured out a way to do that. And so we got these really exquisitely, very high resolution pictures of the rings by being able to move and keep the shutter open and move with the rings. Actually, Cassini was the one doing the moving, but we took out the motion of Cassini to look at a spot. Imagine as you're driving by a house, you sort of want to aim your camera and stay on the house. And so that's what the Cassini spacecraft had to do.
I've a couple of philosophical questions for you before we talk about your early years just growing up and what led you to where you are now. What's the most powerful lesson that you learned from Cassini?
And one of the most, yeah, go ahead.
Well, and I guess the second part of the question, just for clarity, is, and how can that lesson or these lessons be applied to us down here on Earth?
Yeah, I was thinking more in a human sense. I think a very powerful lesson is how important teamwork is. If you get a group of people together working as a team and being able to say, okay, what's the best that we can do for the overall science of Cassini, not just for my science, but to look at the big picture. And I think that was really a powerful lesson, so wonderful to see as part of the international collaboration. On the Cassini side, and looking at what we did with Cassini, it's to keep your eyes open wide. Always expect the unexpected. And a perfect example is those geysers coming from the South Pole of Enceladus, that everything we thought we knew, this tiny little moon, 500 miles across that could fit between LA and San Francisco, should have been frozen solid long ago. And yet, somehow it had these geysers coming out of the South Pole. We went on step by step to make discoveries. Turns out there's an ocean underneath Enceladus's icy crust. And at the bottom of this ocean are hydrothermal vents, places where warm water is coming up from its rocky core. And it turns out as Cassini flew through those geysers, they measured all kinds of organics and salts, not just water, but a whole host of things that perhaps might lead to an area in the ocean that might have life. And so who would have guessed when Cassini launched that we might find a place 10 times further from the sun than the Earth where there might be an ocean that might have life. And it's so tremendously exciting. So just to expect the unexpected, keep your eyes open, and just enjoy. So in the case of Cassini, just enjoy that opportunity.
When you say warm waters, are you talking about 70-degree water? Or are you talking about 1,000-degree? I mean, is it relative to temperature here on Earth?
Right. Well, a good example is they're the equivalent of these hydrothermal vents we saw in Enceladus right here on the Earth, deep on the seafloor of the Earth. They're called black smokers or white smokers. And there what happens is hot water comes out, the little chemicals in them condense and can form black clouds of particles or white clouds of particles. And that water is near the boiling point. And so we saw evidence on Cassini of tiny little grains, in this case of silica, that can only form in water near the boiling point. These tiny little grains came out, Cassini captured them and measured them. And so bit by bit, we had other clues too, that there might be something on the seafloor, that warm water providing the heat energy, and then the nutrients with all of the organics coming out. So you have the basic building blocks. And did life get started in this deep, dark ocean on this world so far from the sun?
Well, it's reminding me in a way. To me, it seems like that perhaps Jacques Cousteau was one of the first space explorers, but went down instead of up. There's because you're drawing a comparison to the depths of the ocean and the depths of the universe.
That's right. That's right. The depths of the ocean are vast.
Yeah.
And these hydrothermal vents on the Earth's seafloor are a relatively recent discovery in the last few decades, because, as you say, the chance to go deep into the ocean and look. And what's so intriguing is when they first saw these black smokers and white smokers, and they ran their cameras on them, what they noticed is these islands of life, tiny little crabs and tube worms and little blind fish in an island. Because if you get too far away from your heat source, then you don't have the heat and the food. And so you literally have islands of life on the bottom of the seafloor. And it was an incredible surprise. You can go online, Google black smokers or whatever, and find pictures.
So take me back, Linda, to you being a little girl. Where'd you grow up? Siblings? Were your parents in science, or were you just sort of the family brainiac or geek? Or
Yeah, well, I was actually born in Minneapolis, and when I was very young, then moved to Memphis, Tennessee, there for a few years, and then came to California. So I was about third grade. Came to California, and here's this little girl, and she comes with this wonderful Southern accent. I'd learned to read when I was in the South, and people would sort of stop and kind of listen carefully. And I thought, these people speak so fast here in California. But as I was growing up, I had parents that encouraged me to basically follow my dream, do what I was interested in doing. I really enjoyed math and science, and got a little telescope when I was in third grade, and I used it to look at Jupiter and at Saturn and the stars, and I thought that was the coolest thing. So as I was growing up, I thought, wouldn't it be wonderful to be both an astronaut, because that was the time we were sending men to the moon, and an astronomer. And I figured it out. I had a whole plan laid out. I'd be an astronaut, and when they went to the moon and built this base on the moon, on the far side of the moon, surely they'd build a really cool telescope. And I could go and I could use that telescope on the moon to look at the universe. Well, I'm still waiting for them to build a telescope on the moon. But I always had a love of science. And then I went to Cal State Fullerton, majored in physics. And not long after I graduated with my bachelor's in physics, I got married and I was looking for a job. And that's when I applied at JPL. And they offered me the opportunity, do you want to work on the Viking extended mission? Viking was winding down. Or we need someone to work on this new mission called Voyager. And I said, I've never heard of Voyager. I know about Viking on Mars, but where is Voyager going? And they said, well, Jupiter and Saturn, and if all goes well, on to Uranus and Neptune. And when I heard they were going to go to these planets I'd looked at with my little telescope, I said, sign me up. I want to work on Voyager. And so I did. I got my job at JPL. A few months later, there I was at the Cape watching Voyager lift up off the pad, start its journey, and I was off and running at JPL. And what a wonderful experience. And people often ask, how do you factor in a family when you're working? And so really kind of a fun answer that I give is that the way the Voyager flybys went, 1979 we flew by Jupiter, 1980 and 81 Saturn, and then there was a 5-year window until our flyby of Uranus. And I decided that's the place to start my family. I wanted to have a couple kids, and so I thought, okay, if I can, to this day, you can plan these things, have a couple of kids, and be ready then by the time I got to Uranus, having started my family. And as it turns out, I was actually fortunate enough to be pregnant and be carrying my first daughter during that second flyby of Saturn. And so it did work out. And I wasn't the only person that had kids in that time window on Voyager. We actually had a little softball team, and we'd bring our kids to the softball games, and there were a lot of kids for my 2 daughters to play with on that softball team. So,
well, it really is an extended family. I mean, that's one thing that was very clear at my visit and from speaking with you. And I think it's, some of it might be, well, obviously the shared passion and interest and that you have for space exploration, but also, the 16-hour days, I would imagine, that you spend together. It's kind of like making a record, or working on a TV or film. Like, you're working until you get it done sometimes. But you also, again, you have had fun along the way. Yes. You have the softball games and barbecues and things like that, and I think it's just nice to hear that. There's that's probably part of what makes and allows you to be there for so long.
Yeah, Terry, I think that's really true. In fact, some of my best friends, one I met when I was at Cal State Fullerton working on my bachelor's degree, and she came to work at JPL. Mm-hmm. And then another very dear friend I met early on Voyager, and we've stayed in touch. Our kids have grown up together. We've traveled together. We still talk to each other regularly. And you're right. It's like part of a family. And you grow up together, and you have the similar experiences and travel together. And that makes it really a lot of fun, too. Fun place to work at JPL.
Yeah. Well, so, and while you were working at JPL, they encouraged you and made it possible for you to go and continue your education, going on to get your master's and your doctorate. How did you manage, how did that work? And also, how did you manage to balance your time? Now, 3 places: work, family, and continued education.
Right. That indeed was a challenge. For the master's degree, I would go to classes at night. And so they had a program specifically designed for people who were working. And so that worked out quite well. And my husband was gracious and willing to watch the kids, so I'd go a couple nights a week. And he was actually going to school too. And so I started that before I had kids. So I was most of the way done with my master's before I had any kids. And then the PhD, what was really nice is I had used Voyager data along the way to write a series of papers about Saturn's rings, and watching as a star would go behind the rings. And as that star would, you can imagine, the more particles in the way, the dimmer the star, the less, the brighter. And I would use that to look at the waves in the rings. And so I had these papers that I could put together then when I went to UCLA for my doctorate to put into a thesis. And I had taken a lot of the coursework for my master's. So I was really just taking a couple of courses, a few courses at UCLA, and then putting together some papers. And then, of course, you always have to have a new idea that's new and fresh and something you've worked on. And so I did have an idea, and I used that as part of my thesis. And JPL was very gracious. They paid the tuition and the books, which are a whole lot less than they are these days. And they just asked that for every year that you go to school, you just agree to work 1 more year at JPL. And I really enjoyed it there, so that was very easy to do as well.
That's a very reasonable ask and barter.
Yes, absolutely. It was a great trade.
Mm-hmm. Absolutely. Uh, one of the things you're talking about wanting to be an astronaut. And so have you ever gotten to experience weightlessness or any of the simulations? I mean, do they let you at any point of your career get in there and try out some of the cool things?
Yeah, I haven't had a chance to do that, although NASA does have a plane, and it has a nickname called the Vomit Comet,
Hmm.
where this plane goes along and then it dives down and gives you a few minutes of free fall, and you can
Hmm.
do science experiments or whatever for free fall. So I haven't had a chance to fly on that plane, but some friends of mine have tried it, and they say, yeah, you've really got to be ready. It's your stomach just drops, when you fall. But I've had a chance to go skydiving, and one of those was a tandem jump. And so I did get to experience something very close to free fall. Of course, you have this air pushing on you and rushing up, but you're falling, as fast as you can in the air until you open up your parachute. And so
Hmm.
that was really a lot of fun. So that's the closest I've come to free fall.
Well, you also enjoy bungee jumping. I know you did that on your in New Zealand, right, for your honeymoon?
That's right. That was right. Really fun. The Kaikoura Bridge is where
Hmm.
they actually originated bungee jumping. And we went there and we watched for a while and we said, do you want to do this? I said, yeah. And I said, okay, let's do it. So we each did our own bungee jump. You have to walk out on this little platform, like walking the plank on a pirate ship. And then you have to jump off the end, and then you fall, and then these cords catch you as you get to the bottom, and they say, do you want to put your hands in the water, do you want to put your head in the water, what do you want to do? And I said, okay, first I want my just put my hands in the water. So we each did our own jumps, and then we decided to jump together. So we did a jump together, and we said, okay, we want to put our heads in the water this time. So we did that, but that was really really a lot of fun.
Is your husband as adventurous as you are?
Yeah, he's adventurous. He has more skydives than I do.
Hmm.
He's an engineer and a scientist, currently retired. But what his dream is he's working on the idea for a giant space station, a giant rotating space station, so you could at least get lunar gravity at the outside, and it would be part research and part space hotel. So I told him, yeah, when they build it, reserve us a ticket so that we can go.
I could see you there. I could see you just getting a one-way ticket too, except for missing your kids and grandkids.
Yeah, I think it'd be great, if it gets built, to go there and just to look down at the Earth. That must be so, so tremendous to look down at our own planet and realize what a special place we have.
One of the things that I'm very curious about is the your creative process, because in the little that we know each other recently, I see a lot of parallels. You had said that the beginning of the Cassini project started with an idea. The same as when I write a piece of music, and oftentimes the inspiration comes from unexpected places. As you said earlier, expect the unexpected. Is and I'm wondering, do you walk around getting ideas from unexpected places?
If I'm thinking about, some kind of research or something I'd like to do, something to do with the rings, I read. I read a lot, both read newspapers and nonfiction, but also read some books. And sometimes there might be an idea or a different way to look at something or approach something that I might see or that I might get. Also, just talking with people. That's the beauty of going to these conferences and going to these meetings and just starting to throw ideas around. And often you'll go down a path that you hadn't even thought of initially. Maybe it's a lot like writing a song. You kind of go down one direction and maybe something else sounds good that on a different day. And then you go down that direction instead.
Well, and also one of the most wonderful parts for me about collaboration, and it sounds like your experience is similar, is that when you are interacting with other people who have their point of view and you look at it through their eyes and their perspective, other things happen to the idea or to the song or to the mission that are better than it might have been if you were only looking from your point of view.
That's absolutely true with science as well. When you get a team of scientists together looking from their different perspectives, sometimes from their different wavelengths if they have different instruments that they're representing. And it's when you take those ideas and put them all together that you might get something that's bigger than any single idea might have been.
Mm-hmm. What's going on with the space program right now in the United States and also globally? It sounds like it's getting a renewed sense of funding, perhaps, and energy. That there's maybe been a little bit of a lull from the public point of view on this. That doesn't mean you haven't been working around the clock for 40 years on it, but what do we have to look forward to in the future of space exploration? What's coming our way? What's exciting? What are you working on that you can talk about?
Now, well, something very exciting that JPL had a big hand in was the launch of the recent Mars mission. And that Mars mission, they continued to build it and had to put the rest of this rover together and put it on the spacecraft and launch it all during this time when we've been locked down. So it's headed to Mars. It'll get there, it'll land, and its job is to collect samples. With these samples in little tiny titanium tubes, and then another mission will come back, collect those samples, and bring samples of different kinds of rocks and material from Mars back to the laboratories on Earth. And they can start to look at them to see, they're trying to land in a place where maybe there was water then in the past and look for past evidence of life. And perhaps long ago when the Mars climate was very different, there might have been life there on Mars. To me, what's very exciting is that a lot of the advances that we've made in launching, you've got industry now really being a big player with the recent SpaceX launch to the space station and then the landing. It was so exciting. I was sitting there watching as those parachutes came out.
Weren't they beautiful?
And it's beautiful. Those 4 parachutes in the capsule landed in the ocean. And it took me back to those, Mercury, Gemini, Apollo days. I'm watching those missions. I often watch with Walter Cronkite and have vivid memories, especially of the moon landing. So seeing that, and they're teaming up with NASA, looking at missions to go to the moon, hopefully soon, and possibly to land people on Mars. I think that would be tremendously, tremendously exciting. And on the planetary side, we have another mission that's getting started, launched probably 4 or 5 years, to go back to Titan, Saturn's moon Titan, and to land with a really cool, to land with a quadcopter. The atmosphere of Titan is about 4 times denser than the atmosphere here on the Earth. So it's a very thick atmosphere and the gravity is a whole lot less. So you can imagine flying one of these little drones essentially and landing on different places on Titan. It's a big drone. It's not like some of the little tiny ones. It's a big drone.
Right. When you say little, how would it be, like 6 feet, 10 feet, or is
probably something on that order. It's not just a few inches. It's right. Quite a large, like a large drone and quadcopter, and it'll take samples. Has like a little vacuum in one of its feet, and take out bits of Titan and put it in their little internal laboratory and run some experiments on it and measure the weather and the temperature and take some really very fascinating images of Titan as well. So that's coming up, and I think that'll be a very, very, very interesting mission. And NASA has competitions periodically. There's one that has 4 missions to Venus and a mission possibly to Jupiter's moon Io. And my favorite is to go to Neptune and fly close to Neptune's moon Triton and see if Triton might have, we know Triton has geysers from the Voyager flyby in 1989, but find out more about those geysers. Is this little moon Triton kind of a lot like Enceladus? Actually, and Triton's quite a bit bigger than Enceladus in size, but do we have another ocean world, what we call ocean worlds, with an ocean underneath an icy crust? So lots in the future and looking forward.
Listening to you speak about being a young girl and the first moon landing and, all of those incredible things that we experienced as kids growing up in the United States, they just remind me so much of a time of marvel the great wonder of the unknown of space. And I'm wondering, from that, to watching the Jetsons growing up and seeing things that hadn't been invented yet. But what do you think has changed the most in space exploration during your career, and what's remained the same?
I think what's changed the most is that how much smaller you can now build a very similar kind of instrument or spacecraft, that the components, the electronics, everything has gotten miniaturized and much smaller compared to, if you look at the Apollo, spacecraft, or even Voyager. The Voyager computers were about as smart as the computer in your key fob to open up your car. Mm-hmm. So the computer was very, very limited in what it could do, but very capable for its day, but so much more capable than what we can do now. I think what stayed the same is our curiosity, wanting to know, what does it all mean? How do we fit into the big picture? The big burning question, is there life elsewhere other than the Earth? And what does that tell us about how life might have gotten started on our own planet? That's such a burning question. Also, I think what's interesting is, when I was growing up, we didn't know if there were planets around other stars for sure. And now with the more sensitive instruments and missions that we have, we're finding that lots of stars have planets, in some cases, multiple planets around the same star. So these new exoplanets, as we call them, come in all different shapes and sizes. Lots of them are Saturn to Uranus and Neptune size, super Jupiters, and trying to understand these systems and then ask the question, can we make our instruments good enough where we can start to look at their atmospheres and look at those planets that are at the right distance from the sun that could have liquid water on their surface? And can we look at those little planets and see if there might be life very, very far away in other solar systems? So that's something I think would have been hard to have guessed when I was growing up, that we'd actually be able to see little planets or big planets mm-hmm. around other stars.
Has your work, and I think this question would apply not just to you and your husband, but also to the people that you work with, is there a deeper sense of spirituality or any kind of has it changed your perspective on religion and spirituality from being a scientist and just continuing to look outward?
Yeah, it's just pretty awesome to think about how vast and how different the universe is, how beautiful the universe is, and wonder if perhaps there's some grand creator that, whether it was the start of the Big Bang or whatever process occurred that really got all of this going and is sort of creating or maybe sculpting, the planets and the stars going on. So there's just tremendous beauty out there. And I think I'm kind of in awe because mm-hmm. I feel like as I learn more, I realize how much more there is I don't know and would like to find out.
Another parallel with being a creative artist. The more I learn, the more I understand that I don't know. It's and that's what I love about it. It's a never-ending journey of becoming better. As with the skills that we have, but also as a person. Becoming a better person, and striving to continue to be open to the possibilities of things that you might not have experienced yet.
Right, and just learning and watching with Voyager and Cassini, whenever we thought we had the answer, it would turn out we were wrong in a very spectacular fashion.
But you're smiling when you say that.
Yeah, that's right, because that's half the fun of being an explorer and going out there and answering those questions.
So you don't view that as failure?
Oh, no, not at all.
Nor do I.
No, it's success for sure.
Yeah. So I guess a little bit further with this question, are there a lot of atheists that are scientists, or is it no different than anything else? I guess I'm asking the question because, again, my visit to your lab and watching everything in a way was, there was a spiritual aspect to it for me. I'm not talking about religious. I'm just talking about the wonderment of it all, and it being so much grander than this little speck of dust, that I take up in the universe.
Right. Certainly the grandeur and very, very humbling in that sense.
Yeah.
probably with scientists, with engineers, there would be a mix of people that are atheists and others that in various ways believe in something bigger perhaps than we are, and a different kind of connection perhaps than just the physical connection, the spiritual connection.
Mm-hmm. But you use the word awe, and I think you would have to really pretty much be brain dead to not be in awe of all the marvelous things that you have been able to see. Yeah,
Absolutely. Just incredible, unexpected. A good example is there's a 6-sided jet stream at the North Pole of Saturn, a hexagon. Why is it a hexagon? What keeps it there? We don't know, but it's beautiful. Beautiful to look at and see.
And it's constant?
Yes, as far as we know. Voyager's just caught it edge on, and with Cassini we could see a full view of the hexagon. Just so many things that are out there, not only scientifically interesting, but also extremely beautiful as well. Kind of speak to the heart as well as to the mind.
You mentioned earlier that Cassini originally had a different name. So how did she get her name?
Well, initially starting out didn't have a name, but the name Cassini comes from the scientist who discovered a gap between two of Saturn's rings. The A ring and the B ring, there's a gap discovered by an astronomer named Cassini. And so it just seemed appropriate to name the mission after Cassini. And then the Huygens probe on the European side is named for the scientist who discovered Titan. Mm-hmm. So what better name for a mission than the discoverer of Titan?
Yeah, how fitting.
Yes.
Do you have anything named after you, or is that even a possibility in your career?
No, it is possible. No, I don't have anything named after me. If you discover an asteroid, you can pick a name for it. Mm-hmm. And so some of the people that discover lots of asteroids might name them after friends, family, can pick whatever name that you mm-hmm. would like for that. Or if you discover a comet, they'll often give the names of the discoverer of the comet.
What was it like when you received your first big award from NASA? Because you've been awarded multiple times, and I'm sure each is more thrilling than the last. But what do you remember about the first time?
Yeah, I remember just feeling very happy and very honored to have gotten this award. Very proud to be recognized, and realizing at the same time that it was really, again, that family or that team supporting me that really helped me get to the place that I was at that would lead to this award. And the first one was when I was working on Voyager. Mm-hmm.
You have a couple of different job titles that I read in your very long resume, and I'm curious if you could go into a little bit of detail about them before we wrap up our conversation and get a little more personal. One of them is co-investigator with the Cassini Composite Infrared Spectrometer team. First of all, what is a composite infrared spectrometer, and did I say that correctly?
That's correct. Absolutely, Terry. That's correct. The composite infrared spectrometer is one of the instruments on board Cassini. Mm-hmm. And so the various instruments have teams of scientists. The principal investigator leads the team, and he or she has co-investigators that work with them. And so back in the 1990s, when they picked this instrument to fly on Cassini, I was then on that team. I was part of that team. Actually, I was part of the Voyager team, and they saw me, sort of maturing and getting my PhD, and they said, "Hey, come and join us. You'll be our ring scientist for the composite infrared spectrometer." So I worked with a wonderful team of people, again, international. We'd have meetings in different places with the infrared spectrometer team. And so I'm the lead for the ring studies, brought in postdocs, other scientists to work with me on trying to understand if you could hold a ring particle in your hand, what would it be like? Would it be like a fluffy snowball, which is what we think it would be like? Would it be solid on the inside? Learning more about that ring particle.
And what does a discipline program manager do?
A discipline program manager, in this case, that's sort of a new role I have at JPL. And what I do is I help look at other people's proposals they're going to submit to NASA. within a certain group of proposals, say the Cassini data analysis program. And I read through their proposals and I try and give them ideas and advice, and I edit to try and make their proposal as strong as possible, because it's a competition to get funding within that program. So I help other scientists and use experience I've had writing proposals too.
And I believe your main title was or might currently still be JPL Principal Research Scientist, or is that just another aspect of what you do?
Right. That's just a title. I'm in the science division and work with a team of scientists. And then the other title, Cassini Project Scientist, that's where I'm the lead scientist for all of the scientists on board Cassini, and my focus is to try and maximize the science return across all of the different types of science: rings, moons, planet, magnetosphere, within the cost and schedule and budget. So I have to look at it from that aspect too.
So is part of your job, it's almost sounding like similar to me being a record producer, where you are a liaison between the budget people, the money people, the client perhaps, and then the talent, which would be your team of scientists or the musicians. Is part of your job is kind of being a team leader and cheerleader and coordinator and keeping people on point?
That's absolutely right. And trying to keep them focused and trying to find a good balance, because everybody wants to do everything, and the bag can only get so full. And so it's working together with those people to try and get the best possible science that we can. And sometimes just helping others see another's point of view. If there's a conflict, then that's where I have to step in and listen to the two sides, and perhaps then decide what path to take, or better yet, get them to find a compromise. If they can see each other's points of view, often there's a compromise if each side gives just a little bit.
Is that a skill that comes naturally to you, or did you learn it as a little girl growing up in your family, or did you learn that working on your doctorate and as in an actual class on how to compromise with people and how to have leadership skills? Where did you learn to do that?
Probably first started with having three sisters.
Compromise.
In the same house. And learning how to get along and sharing a room and that sort of thing. And that was probably the initial start of the experience. And then I think, working on projects maybe in college or in school with groups of people and learning to negotiate and compromise and how to make your point of view known as well.
Linda, do you have a favorite movie, like a favorite sci-fi movie that best artistically represents space exploration? Is there any one that really kind of nailed it for you?
Well, I'm a big Star Trek fan, and from the early days of Star Trek all the way through the more recent Star Trek Discovery series, and just kind of writing along and looking at their view of exploring the universe and what might be out there. One of my favorite movies is 2001: A Space Odyssey. I just think it's just really a very, very fascinating movie about going out there and what might happen. So I really enjoy that movie too.
How far are we from having a holodeck? Can you make that yet?
Well, I don't know if you've ever tried on those 3D glasses.
I haven't yet. No.
Oh, they have some where you can put them on and all of a sudden you're standing on the surface of Mars. And you look around and you're having a view that one of the Mars rovers might have. Or another one, it was to try and give an example of what it might look like inside a computer. And I remember sitting in a chair and it was like, they moved you to the edge and you're looking down on this vast, like matrix-like network. And I remember holding on to the sides of my chair because it was so realistic. So some of these 3D glasses and what they can do is pretty amazing. So.
I'll have to try.
But as far as the full experience, I don't know. I guess what California Adventure has this ride where you're sort of soaring over various things, and then they spritz you with orange blossom spray or pine spray, try and get you to feel like you're actually over an orange grove or a pine forest.
I just love that you could walk in and have a dinner in a Parisian cafe or have a martial arts fight with an opponent in a style, unknown to man. And, I guess it's a little kid in me, that marvels at all the possibilities.
Right, right.
Speaking about not just science and business, but what causes and what things, in addition to science and family, are close to your heart?
Well, I think in looking at what's happening most recently, I think it's just really important to be respectful of equity, diversity, inclusion, to include everyone and make sure that whether it's within sciences or whatever, that you have good representation across the board on that. And I just, feel very, very strongly how important that is, especially in the time that we're in right now.
Mm-hmm. Without putting you on the spot, is NASA and JPL pretty on board with that kind of thinking? Are they forward thinking and inclusiveness?
Yeah, I would say yes, they are definitely forward thinking and are developing even more programs now to look into that and find a better balance. And even within NASA, this is a very important aspect, I think, as well. And one of the things I watched as my career has progressed is how things have changed in a very positive way, especially, I think, as a woman, going from the early days where often I could be the only woman in the room at a meeting or very few women in a room for a science meeting, to now, working on some of the Cassini teams where you have far more women and a more rich diversity of individuals all contributing together. And I think that change has really been a good one.
I get the feeling that one of the things that you most enjoy about your job is you're traveling and you're public speaking because you're so at home with it. You're enthusiastic and passionate and articulate, but you make it really easy to understand all of the things that could be, very heady. And
well, thank you.
Yeah. Is that true? I mean, do you enjoy it as much as it appears?
I do. Like I said, I like to try and tell the story of Cassini, and then sometimes weave in my own personal story with my daughters and where they were at various points in my career. But I really enjoy telling the story. And what I really miss, if you talk at a virtual conference, I talked virtually at a conference recently as a keynote speaker, and you could just see people as little boxes on the screen. And I miss that feedback that you get with the audience, and you can look out into the audience and you can tell, am I really getting them as interested and enthusiastic as I am about it. And with the Zoom, you can see like the little hands clapping maybe or something. But,
or this.
That's right. Yes, that's right. Because everybody's muted.
Right. This so for the people that are listening are just hands waving in the air.
Hands waving, yes, that's right. Because everybody's muted. There's too many people to speak. But so I do enjoy that. Yes.
Well, there's energetically, I mean, it sounds very much like when we perform music live, you feed off of the energy of the people in the room in a way that's slightly different than when you're in a room collaborating with people. But when you're presenting a song or a point of view, an idea, you respond. It's an exchange of energy. And I absolutely understand why you're missing that, because we're missing that too in our virtual performances and things like that we're doing right now.
That's an excellent way to put it. It's a feedback. It's a feedback loop with the audience.
Absolutely.
And you kind of feed on that energy, and it makes you able to do even better, I think. Yeah.
Right. Or adjust.
That's right. If needed, to adjust. Absolutely. And I really enjoy at the end the people coming forward with questions and wanting to know a little bit more, or, for me, perhaps I get introduced to someone's son or daughter that might have an interest in science, and having a little bit of one-on-one time with, some young person. And I think that's really exciting too.
So mentoring is important to you? Yes,
absolutely. I enjoy that. Yes, I've had a number of postdocs that have worked with me throughout the Cassini mission, and have had a chance to help them grow and sort of launch their careers. And that's very satisfying to be able to do that.
Linda, what lessons about science and art and life have you learned on your journey?
Wow, that's a big question. I think maybe overall I would say follow your dreams. Don't be afraid to listen to that voice inside, telling you where your heart might be, and to follow those dreams. And for me, that's just been the most rewarding, to when I follow my dreams and find something I'm passionate about, then I also enjoy it very, very much.
As do I. I can relate to what you're saying. What has changed about your perspective as you've gotten older?
I think perhaps my perspective has gotten bigger, wider as I've gotten older. I've gotten to see, I guess, through the lens of different ages as I've progressed, from being a young woman to being married to having kids and now grandchildren, and now getting to close to the time of wanting to retire and perhaps move on and do something a little bit different, maybe do something a little bit different.
Mm-hmm. Yeah, I was going to ask you, what might that be? Yeah, writing, I would imagine.
Writing,
more hiking, maybe
hiking, working with a university perhaps in their program. Like I said, really, you hit the nail on the head. I really enjoy mentoring. I would enjoy working with students in a different way than I'm working with, say, perhaps on Cassini, but maybe working with students, moving maybe to a nice university town and taking part in that university's activities.
Yeah, LA, having also not been born here, I grew up in Miami and then moved here after college. It has so much to offer, but it's also, it's a good place to leave, and take your experience and kind of maybe bring it down a notch so that you can enjoy the quality of life.
Exactly. You hit the nail on the head. The place where there's maybe not quite so much traffic and quite so much busyness, but there's a lot of good places to go. And LA does offer a lot, but there are a lot of other places that offer a lot too. Maybe a little closer to Yosemite.
I was thinking. You've done a really wonderful job of balancing your career and your family, and your physical and mental health as well. That's what I'm hearing from speaking with you. Has that been a challenge, or is that just kind of your natural instinct to make sure that you've included balance in your journey?
I definitely think balance is important, but I have to say it's not always easy. There are some times when, especially with my job, it just gets so exciting and very demanding, and sometimes almost overwhelming, and trying to find that right balance. So I think maybe that's the biggest challenge, when to kind of pull back a little bit and find more family time.
Before I ask my final questions, would you mind sharing what your takeaway is from those final moments with Cassini? Because it was very emotional watching it. You sent me a video to watch, and it was already very emotional 7 days before. But those final moments seemed very special. My observation was there was a sadness, but which was outweighed substantially by the amount of pride and love and sense of accomplishment, not in an ego way, but just there was, it was, in a sense, there was kind of a hospice moment. It's like it was the death. I viewed it as the death of one of your children, that you conceived literally and grew and nourished and guided literally.
Right. Yeah. In so many ways, that's true. And you hit the nail on the head. There's a tremendous sense of pride in all that Cassini had accomplished, all she had done. And yet Cassini was an extension of us, of the Cassini family. And so we had basically put our imprint on this plucky little spacecraft there for that final dive in between the rings going into the planet. And for me personally, we had sort of built up to that moment day by day. knowing the time, the day, the hour, almost to the minute when that final end would occur. And so we were all gathered in a room in Mission Control. A lot of people were gathered down at Caltech or at JPL watching on screens. I remember watching this particular little screen that had this green peak, and that green peak meant Cassini was still communicating with the Earth. And as long as I saw that peak, I knew, okay, Cassini's hanging in there, she's hanging in there, she's hanging in there. And then slowly that peak started to decrease until that peak was gone. At that point, I knew that the atmosphere of Saturn had gotten so thick, Cassini had no longer been able to hold that focus with the Earth and had turned away. And then very shortly thereafter would disintegrate, burn up in the atmosphere of Saturn. And you could just, for that brief moment, just feel the quiet when that signal disappeared, and everybody just kind of like, oh, it's over, it's really over. And then the project manager very gracefully, turned and said, I called the end of the mission, and he gave the time to the second, of course. And everybody just, started crying. That was sort of the natural reaction, is to start crying and hugging each other. Mm-hmm. People stood up and started hugging each other, and it was like important to share in that moment. And I found some of my friends in the room, and we just shared that moment together. And my daughters were there. My granddaughter was there as well. And so afterwards I went to see them, and they had also shared in that final moment for Cassini. So it was very emotional. Wow. that final moment. I remember kind of leading up to it. It's kind of like, the mission's going to end, and it's kind of like you sold your house and you go room to room and you look sort of for the last time. Okay, yeah, here's the bedroom where I grew up. Here are all these things that happened, and now I need to close that door, and move on to a different chapter. And so in a sense, those final moments, some of the videos that were put together were just those final moments looking back and thinking about Cassini, and then afterwards just sort of sharing with one another some of our best memories. And all throughout that week, we had the scientists there. We were meeting down at Caltech, and we were sharing and remembering some of the very best things about Cassini.
Linda, thank you for sharing that with me. It's quite moving still to me, and I know for you as well.
Yeah, get a lump in my throat to this day.
Yeah. And perhaps even more so because the third anniversary is coming up on September 15th.
That's right.
Of that day.
Right. And so appropriate with your song that you put together, Cassini's Last Dance. Yes, so appropriate.
Well, again, thank you. And again, inspired literally by your team and the work and the love and the commitment and the passion and the curiosity and I could feel it, and I still feel it. I feel it again having the opportunity to speak with you. But it's to me so much more than science, or perhaps maybe that's what science really is, and I never knew it.
That could be, yeah. A journey. It's a journey, a process.
Yeah. Absolutely. What are you doing to celebrate? Is it a happy day, a sad day? Is NASA doing anything? Is JPL doing anything?
I'm not sure if JPL is doing anything this year. This is a little bit different than we've had in the past. It's the third anniversary. There might be something more perhaps for a fifth anniversary.
Yeah. The big numbers.
One of the things I'm going to do, I'm going to send out your song on September 15th.
Oh, how fantastic.
They'll just tell you, the Cassini team, and they'll have a chance to share on that day. I know that's times when people, sometimes they send around their favorite picture, perhaps, either from Cassini or maybe a picture of people, some of the people that they worked with. So there'll be a chance to remember in some way or another. We will do something, yeah.
Well, I'm touched and honored, and that's really just cool. But I'm forever changed by your collective experience. I truly am. I want to ask you my closing questions, and the first of the three are: since the show is called Making It, what does making it mean to you, both professionally and also personally?
I think professionally making it means that I get to, like I said, follow my dream and get to be part of these incredible missions like Cassini and get to be an explorer and help answer some of those questions. So I'm just so tremendously happy to have been a part of being able to do that. And then on the personal side, I think it's wonderful now to watch my grandchildren start to grow up. The oldest is 11, and the youngest is just turned a few months old, actually. And so I think that's so important then to pass along my love of the planets, my just all the experiences I have to share, not only with my children but with my grandchildren. So I think that's very important to do on the personal side.
And since there's so many women in your family, you know, to be able to pass on and continue to help guide the next generation of powerful women, you know, who are curious and also passionate, because I would imagine that you were passing on the same encouragement as your parents did with you, which is to follow your dreams and do what you love.
Right, absolutely. Starting now. Yes.
Mm-hmm. Yeah, that's the best time to start. Can you share 3 tips for success that have driven your career?
I think mentoring is key. If you have people that you trust that you can ask questions and they can help mentor. I've had some wonderful mentors, both in college and while I've been at JPL. So I think that's really a very important one. I think to trust yourself. Sometimes it gets so easy to get caught up in what do other people want me to do? What are other people thinking? Sometimes at the end of the day, you have to just sort of trust yourself and do, what you want to do. And then I think have fun, find something that you really enjoy and have fun with it. That'll make it just a much more interesting and lasting experience if it can be fun as well.
And before I turn it over to you for your final closing thoughts, if you have any, my final question is, at this point of your life, with everything that you know to be true, what would you tell your younger self if you could?
A lot. Again, probably the advice to trust yourself. To trust in yourself and that it's going to be okay. Everything will work out. There'll be times, that it doesn't look like it's going to turn out well, but it will. Just to trust yourself.
Mm-hmm. And on that note, is there anything else that you would like to share before we say goodbye?
I'd just like to thank you very much for the opportunity to be here. And I think you've given me some new insights and some new aspects, new things to think about as well. And just really appreciate that. And I think just in closing would just say, hey, follow your dream. There's a lot out there to explore and a lot to find out about.
Thank you, Linda. Likewise, you've given me new things to think about as well. I thank you for your time. It's an absolute pleasure. I look forward to us meeting in person when it's safe to do that.
Oh, absolutely. I look forward to that, Terry. I really do.
That'll be great. And I want to thank all our listeners for joining Dr. Linda Spilker and I for the last hour and change and giving me the opportunity to share the amazing work and the journey of Cassini and JPL and NASA and you personally. So thanks, everybody.
Tune in again next week for another great episode of Making It with Terry Wollman.